Ladies and gentlemen, and distinguished guests, welcome to UNSW Sydney. We're very pleased to have you here for today's discussion, a jointly organised event between UNSW and Google. Now, we're an organisation that does a bit of research, so we're particularly pleased to have the Director of Research from Google, Peter Norvig, here to present as a part of our discussion. Shortly, I'll be inviting Professor Ian Jacobs to introduce both our panellists for today's discussion. But first, I would like to acknowledge the Bejigal people, who are the traditional custodians of this land where we are today. I'd like to pay my respects to the elders, both past and present, and extend that respect to other Aboriginal and Torres Strait Islanders who are present here today. Ladies and gentlemen, please welcome Professor Ian Jacobs, President and Vice-Chancellor of UNSW Sydney.
Thank you, Mark, and welcome everyone to this very exciting event. In welcoming everyone, I'd like to echo Mark in respecting and acknowledging the Bejigal people, the traditional custodians of this land, and other Indigenous, Aboriginal and Torres Strait Islanders who are with us today. You're all very welcome here, and it's a great pleasure to host you for a landmark event, a discussion between two eminent leaders and researchers on the topic of artificial intelligence. Artificial intelligence, or AI, has captured the imagination with its promise of, amongst other things, driverless cars and personal assistants that we can carry around with us in our pockets. It has also raised concerns about the appropriate use of AI, particularly in its use for warfare, and concerns about displacing jobs in the workforce, but also its ability to predict our behaviour perhaps better than we can ourselves, which troubles a lot of people. Discussion of these issues is really at an early stage, with concern that creation of new technologies is outpacing our ability to grasp the broader social issues that they'll bring out. And today's discussion in that context is very timely and one that I'm greatly looking forward to hearing. When we think of artificial intelligence, one name that immediately springs to mind is Google. And today's event would not have been possible without Google's help, and I'd like to thank everyone at Google for bringing one of their most famous employees, Peter Norvig, to UNSW for this event. Peter is a research director for Google. He literally wrote the book on artificial intelligence, A Modern Approach, which is the leading textbook in the field, and he is one of the world's leading experts in this area. Prior to taking on his responsibility at Google, he led the group working on Google's core search algorithms, and before that, he was NASA's senior computer scientist and head of the Computational Sciences Division at NASA's Ames Research Center. Peter, we are delighted to have you here today. The format of today's event is a discussion between two of the world's most recognized artificial intelligence researchers, Peter from Google and Toby Walsh from UNSW. During today's discussion, we will hear about the current state of artificial intelligence. Of course, over the last 2 decades, we've seen rapid developments in this area. We've seen artificial intelligence programs defeat humans at games like chess and Go. In my field of medicine, artificial intelligence has been used to aid diagnosis for many years, and those at the forefront of this area tell me, or at least they did suggest to me at a recent meeting, that in my area of expertise of complex cancer surgery, it will very soon be replaced by artificial intelligence and robots. And when I challenged this on the basis of what I thought were many years of training on hundreds of complex cancer operations, they very quickly put me in my place by pointing out that computers can learn from and remember every operation ever performed, not just a few hundred. And of course, we're already using artificial intelligence every day through the personal assistants on our phones when buying items online, all through the power of Google Maps. We're very excited about the potential of this area at UNSW. We have a strong history in the field. UNSW is internationally recognized for its research in AI. Through the use of AI, we even hold the title of World Soccer Champions. That's robo-soccer, of course, not the real thing. And that's a fun application of artificial intelligence, but UNSW is also playing a key role in the development of many other technologies that have the potential to revolutionize the future of artificial intelligence. Our Center for Quantum Computation and Communication Technology is looking to develop computers that are capable of performing calculations far beyond those of today's machines. And that has enormous potential for impact through the use of artificial intelligence. So during today's discussion, we'll hear about what is currently possible, what we think will be possible in the future, and what we need to do and be aware of for a proper and informed debate about the use of artificial intelligence. So I'm now going to hand over with great pleasure to Toby Walsh, UNSW Scientia Professor of Artificial Intelligence, to begin today's discussion. There will be an opportunity for you to ask questions later during the event, and you can also post questions on Twitter. This promises to be a very exciting and informative event. Please join me in welcoming Toby Walsh and our distinguished guest, Peter Norvig.
Peter, welcome.
Thank you.
These are really exciting times to be working in AI. Can you tell us about some of the exciting things you're doing at the moment?
Yeah, so I think it is an exciting time. You know, you and I have been doing this for a while, for 3 decades or so, and we get to see each other once a summer or so at a conference. But this is really the phase when the most is happening of all these years we've been involved. And I think this has come about because we've put together the digital data that wasn't there before, the text, the video, the images, the computing power. A lot of the things that we tried back in grad school, we now have 100,000 times more computing power. And so what we could do in an hour today took us, that would be what, a decade back then. And nobody had the patience to run their program for a decade. So we can do so much more now. And true, we have better algorithms and so on. And that gives us the capability to move the whole field faster. And I started out in language understanding and very laboriously worked one sentence at a time, trying to get my system to understand it. And now we do millions of pages at a time. And we do that, we do many tasks at the level of humans. We do image recognition at the level of humans, both for very broad tasks of what's in this picture, is that a cat, a dog, what kind of dog is it? And for, as we heard, these very detailed type of, here's an x-ray, what's the diagnosis, do I need surgery or not? So all these capabilities are coming together to do things we could never do before, and the field is just building on that. Every success builds on a new one. So I'm just excited to see what's going to come up next.
So, I mean, one of the things that people talk about a lot is this idea of deep learning. How much of that is the secret sauce, and what else are we going to need beyond deep learning?
Yeah. So a lot of the applications do come from that in vision and then in natural language as well. And we call it deep learning. And I sort of think if we go forward 5-10 years from now, we're probably still going to be using the phrase deep learning because it's a strong brand name. But I don't know if it'll be the same technology as what we have today, because deep learning can evolve. And I think really what deep learning, the important part.
I mean, they're already adding bits, convolution neural networks, adversarial neural networks.
It started out with basically one architecture, and now everybody invents a new one, but you still put it under the same brand name.
Like the brain.
Yeah, exactly. I think the key is to have models that are flexible enough but not too constrained. You have to hit that sort of Goldilocks just right level. And I think started out, we had earlier models, there was a period of time when support vector machines were all the rage, but they were limited in what they could represent. And so you didn't think of saying, let's try to do machine translation end to end with a support vector machine, because you just couldn't imagine that it could represent all the subtleties that you need to represent. But deep learning, it seems like it's just about right. It captures those. But I think there's things we want to do more. So you've worked a lot in the field of planning, and I think we can't do that quite. We can't do all the things we've done in the past and replace them instantaneously with deep learning. So deep learning is good at pattern recognition, but stringing together a long series of plans, that's going to be a little bit harder.
So we're not going to do we're going to do perception with deep learning, but we're not going to do some of the deep reasoning.
I think that's right. And when you look at things like the AlphaGo, the Go playing program, and that was a hybrid. So it did perception. It had this idea that a Go board, you should basically use almost like computer vision techniques to get a gestalt of what does the board look like. And
am I winning, am I losing?
Yeah, so there's two things. One is, am I winning, am I losing? And the second is, what's an interesting place that I should consider playing? But that's as far as it went. The deep learning part didn't try to play the whole game. And after you did that, then you use the traditional tree search and Monte Carlo rollout and more sort of the old school approach. But it was a combination of the two that allowed us to play at world champion level.
And it ended up making some creative moves, or moves that surprised the Go masters.
Yeah, so even though it was trained to say, consider the moves that you've seen before that were the most probable moves, the search for good moves was broad enough that it could come up with some surprising moves. We had Gary Kasparov stop by Google last week. It was very exciting to see him.
On his book tour, no doubt.
Yeah, his book just came out. He joked that when he wrote a book about chess, everybody wanted to ask him about Putin, and when he writes a book about Putin, everybody wants to ask him about chess.
So what did you ask him about?
We asked him both. But one of the things he said was really interesting is he said, human chess players are pretty close to perfection. And to beat them, you make one or two moves better, and now you've got it. He says, in his opinion, Go players make mistakes all the time. And so in that sense, it's harder to get that kind of perception and gestalt understanding of Go. But once you do, there's a lot more mistakes to exploit because it's such a harder game to play.
So we've seen forced dawns in AI in the past. In the 80s, we had the expert systems boom, and then there was what was called the AI winter, as people realized it was a much harder problem than we thought it was going to be, and people ran away a bit from the field. I mean, there's a real boom going on now. There's the last couple of years, the amount of funding going into the field has been doubling every 2 years.
Yeah.
And for the last 6 years. Are we at risk of having another AI winter, or is this really going to be, this is going to be the point that takes us to human level intelligence maybe, or even beyond?
So I think you want to break that up into two phases, right? So one is, when you talked about the winter, it's both a funding issue and a perception issue, and maybe they somewhat go hand in hand. I think we're going to continue to see funding because this time around we're seeing immediate returns, that you can very quickly say, here's a new domain, I want to try something, hey, I got results that actually worked. Whereas before, it was more you were investing in long-term technology. A lot of the work in the early expert system work you talked about, the money went into tools rather than into solutions. And so tools is a long-term bet that other people are going to buy this and then make their solutions. Now we're going more directly for solutions, and to the extent that that's working, the investments will continue to grow. Now the other part is the perception, and we do risk getting to the point where people say, okay, yeah, these techniques are really good at pattern recognition, and here's one more application of pattern recognition that's really working, but it doesn't seem like we're getting any closer to full reasoning. And so that could be a place where people get a little bit disillusioned.
But to go beyond the perception, there's a technical question there, which is, are we still missing some important technical pieces that have to go into the jigsaw?
Yeah.
Or is it going to be, we've got most of the basics and we're going to have to improve them and we'll put bells and whistles, or are we missing some fundamental things yet?
I think we got a lot of breakthroughs yet to go. If we had everything there, we'd be doing more right now. And you look at the technology that's available, so we can do speech recognition, that really jumped right up. Machine translation, we cut the error rate in half compared to human performance. But the part that remains seems more elusive or not as open to making incremental improvements as it was in the past.
So you're reassuring the audience that they don't have to worry that Terminator's not just around the corner. There's quite a few more years. I mean, what's your way to calm people's nerves when they feel that the machines are just about to take over?
I'd say let's go back to the story of John Henry, right, where there are tasks that people do, and I think we should focus on the tasks rather than the jobs, and say there are parts of what you do that's repetitive and not very interesting, and we have a lot of data on it, and we're probably going to be able to build computer systems to take over those tasks. And then what remains is the part that's novel and new. We don't have any data for it. And those are parts where we're still going to want to have humans to do those parts. So the humans will have very good tools. They'll be able to be much more productive and get their work done. But this partnership of a human with a set of tools is going to be better than handing everything over to automation.
So just to go back to Google, because the title of this piece was to learn from Google. I mean, Google's probably one of the companies out there that's probably had the most experience, the most success in fielding AI and helping to put ideas into practice. Can you tell us, first of all, what are the surprising, I mean, most of us probably are aware there's some AI behind Google Translate and behind some of the search results and behind the speech recognition. But what are some of the surprising things that Google's using AI for that people wouldn't be expecting?
So I think it's everywhere, right? And Google was formed with the mission statement of organizing the world's information. And we do that in terms of information that's available on the web. And we also do that in terms of our own information. And so I think it's kind of built into our culture to say, if you see a problem, how can you address it? How can you optimize it? What data can you collect? And how can you improve on that? So everywhere we have a process, we think of, can we make it better? So the jobs flowing through our data centers, so what task should run on what computer, we optimize that. And some of it we optimize with machine learning techniques, some of it we optimize with operations research techniques. We're always thinking of it in terms of what's the data, what is it that I'm trying to achieve, can I improve? Similarly, the energy in the data centers, the DeepMind team took a look at that and was able to have us save some energy, reduce our carbon footprint by optimizing the way we run and cool the data centers. And so sort of everywhere, we're always asking our staff, come up with an idea to look at what we're doing and improve on it.
So it's becoming like Andrew Ning says, it's becoming like electricity in Google. It's absolutely everywhere. Everything runs on it.
Right.
There's not a thing. So can you help the rest of the planet get up to speed? What are the important lessons you've learned? I mean, one of the things about Silicon Valley is it's supposed to be a place where you learn from your mistakes. So what are the mistakes that you can learn from to save us, the rest of us, the planet, from going down those mistakes?
Yeah, so that's a great question. One thing I'm really interested in is putting together the set of software tools that we're going to need to make this transition from sort of artisanal, hand-coded software that flows out of the fingertips of programmers to a machine learning approach that's formed by trainers, essentially, gathering data and teaching machine from examples. And over the 50 years or so that computer science and programming languages have progressed, we've come up with some really good tools, right? So we build programming languages that are great for programmers to use, and they have all sorts of safety constraints, and they eliminate classes of errors that we used to make. They now disappear, and we've got test suites, and we've got version control. We've got all these great tools for dealing with code, but we have almost no tools for dealing with data. And when you look at the errors that are made by us and our peer companies, it's rarely because somebody wrote the wrong line of code. It's usually because the data
There must
screwed
be
up.
bugs in Google.
There are, and boy, we just had I forget exactly the number, but we just had a round number turnover. I forget if it was 1 million or whatever bugs. We celebrated.
You had a cake with candles on it to
That's-
celebrate
yeah.
your millionth bug.
Right, whoever made the millionth bug had to blow out all the candles. So sure, there are bugs, but when there's a major thing, when Google is down or Facebook is down, you look at the postmortem, and usually it's, somebody screwed up.
Wait, Google's never down. I mean, that's one of the beauties of Google, right?
Well, parts of some services for some people are unavailable at some time.
I mean, unlike
I'll
British
admit it.
Airways, Google's does manage to
There you
go
go,
on.
there you go. And, and when we do have those outages, it's because somebody messed up a DNS entry, not because they wrote a line of code,
data
if
problem.
this, then that, right? And we just don't have the tools, right? We don't have strong typing for data the way we do for our programs. And I think we're going to need to build that up to say, there's more emphasis now on the data and making sure it's correct and verifying it and it's making sure it's not biased and it's fair and all those things. And we just don't have the toolkit.
So, I mean, one of the other challenges is, I guess you're going to say, is that we don't have the people.
Yeah, so that's another thing. And we're addressing that in two ways. One is training, right? And so we've put out course materials, and I got to go back and work on the next edition of the textbook.
That's a great service, Peter.
Yeah, thank you. And internally, we've put, I think, 10,000 engineers through a short course on machine learning, and they all want to know. And we've made materials available to the outside world, both kind of at the university level, and also to encourage younger people to go into computer science, into machine learning.
So,
We'll
I mean,
continue
I
to
think
do that.
your dream is probably that everyone knows machine learning.
Well, I think everyone should be able to do machine learning, but I hope that not everyone will have to really understand it at a deep level. And my hope is that we get to the point where you do machine learning the way people do spreadsheets today, where you don't have to be an expert programmer to use a spreadsheet, but you know a couple tricks, and you can add up this column, and you can sum this, and you can average that, and you can get your job done. And so I think, we need PhD expert level machine learning people. We need, I've taken one course and I kind of understand it level people, but then I think we need even more, everybody whose job involves some analytical thinking, they should have a toolkit that they can use that does machine learning behind the scenes without them having to have that level of expertise.
So something else that you've done that's been fantastic is that you ran one of the first MOOCs. Sebastian Throne ran this AI MOOC that attracted hundreds of thousands of people. In fact, probably kick-started the whole idea of using MOOCs. I mean, where do you see that going next? Is that going to be part of the solution?
I think so. I'm pretty excited about it. And on one hand, I think it's been a great success, and on the other, we still got a long ways to go. We have sort of changed the way that people think about getting their education. And there are a lot of people now who say, I don't need the college degree. I can go take this series of online classes, I can get the stuff I need to know, and I can get a job. If that's what I'm focused on, the whole degree may not be for everybody.
So you're trying to destroy universities? This is not the good place to be telling us this,
So most of the people that are involved in this are past university age, right? So most people who took our course already had a university degree, but it was in something else, and now they wanted this additional training. So I don't think it's affecting that too much. I think it's going beyond that. And I think that's been pretty effective, that you can do that, you can get a new skill, and if you're willing to put in the effort, then that can be pretty successful. What I had hoped would happen, and I think it's really interesting that among the early pioneers in doing these MOOCs was me and Sebastian and Daphne Kohler and Andrew Ng.
All AI professors.
All machine learning experts.
Machine learning experts.
Right? Because I think we all felt if we really understood what was going on, then we could help the student in a deep way. We could say, we can, because we know that lecturing is not the most effective way of teaching, that one-on-one tutoring is. As a society, we've decided we can't afford to have a one-on-one tutor for every single person, but maybe a computer could do a lot of that work. And then the teachers and professors could be there to kind of go around among the students as they're all working with their online tutor, and the human teachers could be supplementing that and filling in when the machine got stuck. And we've had a little bit of this type of recommendation of, you got this question wrong, so we're going to show you this thing next. But we're nowhere near this level of expert level tutor. And I hope people continue to work on that, and we do a better job of figuring out what it means to be able to interact with a student at a much deeper level.
Yeah, and it will help address one of the things you mentioned earlier, which is this concern that people have about jobs changing and they need to reskill, and how are they going to be able to do that if they're about in the workforce already.
Exactly. And so, we've had this model that you go to school for 4 years and you get a piece of paper that says I never have to learn anything ever again. And that's not going to hold up. No. People are going to have to be retrained and reskilled throughout their career. And so what you guys in the university should instill in them is the ability to learn, the ability to be adaptive and change and learn new things. And then outside the university, there'll be these other opportunities to get that training.
So to switch gears a little and go back to the societal questions again, I mean, on Tuesday we had the UK's digital minister say that AI companies and AI researchers are going to have to be more regulated. Well, what's your take on this? I mean, what's going to happen? What is the responsibility here?
So I think it's good that we're starting to look into what the effects are going to be. And I think it's too early to have answers. But if you go back 100 years, we had a great technological innovation in the internal combustion machine. And we just said, this is great, let's get more of this. And it did a lot of good things for us, but nobody at that time was asking, well, wait a minute, is there going to be pollution here? Is the structure of the city going to be taken up by parking lots and streets and made less friendly? We didn't ask those questions, we just sort of muddled into where we are today. So I think it's good that right now, as we start seeing the promise of artificial intelligence, that we're not waiting. We're asking the questions today and trying to figure out where we're going, trying to figure out what the right way to manage this is.
Some people would say that, I mean, we're already starting to see some of the problems. We're already starting to see algorithms discriminate against people in the judicial system, like the Compass program. We're also already seeing, even in search results, people are starting to raise questions in Google Photos, the labeling that's gone on there. That people have, already started to raise concerns. So it's, one of the challenges is that the algorithms don't come with explanations, and the algorithms don't come with guarantees.
Yeah, I think that's right. I think it's also true of humans, right? Right. So,
but you can ask a human.
You can ask a human.
I can't ask deep learning. It will just say, that's the answer. Right? It will just say, that's the answer.
What cognitive psychologists have discovered is that when you ask a human, you're not really getting at the decision process, right? So they make a decision first, and then you ask, and then they generate an explanation. And it may not be the true explanation. And So we might end up being in the same place with machine learning systems, where we train one system to get an answer, and then we train another system to say, given the input of this first system, now it's your job to generate an explanation. We certainly have other ways to probe, right? So we could say, because we have the system available to us, we could say, well, what if the input was a little bit different? Would the output be different, or would it be the same? So in that sense, there's lots of things that we can probe. And I think having explanations will be good. We need better approaches to that. There should be a whole new field of study. But I think explanations alone aren't enough. We need other ways of kind of monitoring the decision-making process of those who are in power.
We want guarantees. Formal
Yeah,
guarantees.
we want guarantees. Well, maybe guarantees, and I think we also want sort of a level of checks, right? So if I apply for a loan and I get turned down, whether it's by a human or by a machine, and I say, what's the explanation? And it says, well, you didn't have enough collateral. That might be the right explanation, or it might be, didn't like my skin color. And I can't tell from that explanation. Mm-hmm. But if I look at all the decisions that it's made over a wide variety of cases, then I can say, aha, you've got some bias there over a collection of decisions that you can't tell out of a single decision. So it's good to have the explanation, but it's also good to have that level of check.
So I can't have an American on stage and not mention something connected to Trump, right? I mean, you did elect him after all, right? So you have to bear some responsibility.
Yeah,
and there's
not in California.
You're saying California's seeding already, right?
Well, yeah.
There's quite a lot of discussion around how the political debate has been changed by the echo chambers that we now live in, that's provided by companies like Google, and the news feeds, again, that's provided by companies like Facebook and Google. Is this a real problem that we're suffering already, and is this how we're going to fix this problem?
So it's certainly a problem, and I guess I don't really believe so much this bubble theory. And I was reading this book, Everybody Lies, by economist and statistician who looked at how segregated are the news sites that people look at. And if people with different opinions went to completely different sites, that would be zero level of integration. And if they went to sites equally, that would be 50-50. And it turns out it's at 45, which is surprising. So what this says is even the racist Nazis read the New York Times. And they enjoy all sorts of parts of it. The crossword
well, you need to know your
puzzles
enemy, right?
And everything else. Yeah, so even taken randomly, right? So there isn't this huge segregation. And I think the reason is because there's only a few big media sources, and so everybody goes to all the big media sources. Now, off the side, they may also be going to their fringe group, but there actually is a wider variety of interaction, but somehow that's not breaking through, right? So they're having this interaction, but they're still voting the way
Part of the problem, though, is it's not just human voices. I mean, the Twitter sphere is dominated by bots. Programs that are, in the sea of computer voices, you can't hear the human voices. And that's maybe also distorting what's happening.
Yeah. And I think we need to help educate people in critical thinking, and that's going to be tough.
So just before we wrap up, I mean, there's a bunch of the journalists and the media in the audience here, and there is also discussion around how journalism is being really impacted in a negative way by technology, by the fact that the revenue stream is disappearing, their journalists are being laid off left, right, and center, and so we're not hearing anymore the right voices. We're not hearing the fact-check news because of technology, and that's actually something that that the technology companies may have to think about their impact on the media. What's your response to sorts of concerns like that?
I think it's complicated. I think we saw a lot of this before there was the internet, when we had, at least in the U.S., we had deregulation of markets, and news sources started to see, boy, if I put more into entertainment news and less into international news, then I make more money. And they were already going in this direction.
But technology has only accelerated that change, which doesn't seem a desirable change.
Right. So that's happened, but technology has also allowed new people to come in and make a living off their blog and so on. So it's a tough problem.
So before we go to questions, we've talked about some of the concerns. I don't want people to forget all of the great benefits. So where do you see, what are some of the best things that you see coming along thanks to AI that's going to make our lives better and not just hurt journalism or the other things that we've talked about?
So I've done some work with the machine translation, so I guess I'm pretty excited about that because it did so much better than I thought it would ever do with this end-to-end deep translation. And I'm excited about that kind of opening up the world and having easier communication between people who otherwise would find it hard to talk to each other.
Good. So if we could have the lights up, we can start taking some questions. Now, as was mentioned, you can tweet questions, and we have someone picking up the tweets. So, Murray, are there any interesting questions on the Twitter sphere?
We don't have any questions yet on the Twitter sphere.
Okay,
but
so we'll take some questions from. There are some mics. I don't know where the mics are. So please put your hand up. And so a question there in the middle.
Yes, hi. My name is Peter. I have a question regarding the coming singularity, where people are predicting humanity will have to make a choice between giving up control to the AI Luddites, becoming a cyborg species, or going down the path of extinction and AIs taking over. So which one of those three do you think personally is going to happen? Thank you.
I think he's allowed to say a fourth one, which is what his view as the future is.
Yeah. So I like intelligence, right? So I work in a field that has intelligence in its name, and we all like intelligence. We named our species after it. But to me, intelligence is only one of the many attributes that we have. And there's some tasks for which optimization of reasoning is really useful. So if I wanted to trade stocks, having a machine that's faster and smarter, I'm probably going to be able to make more money. But I think there's a lot of other things that we do that is not going to be suspect to optimization of reasoning. And if I wanted to solve the Middle East crisis, I don't think I could train a machine to be smart enough to solve it. If it had a super smart machine, it would just get frustrated faster than anybody else would, and give up.
It would just, it's the old classic prologue joke. It would just say no.
Yeah, there you go. Yeah.
Sorry, that was a very geeky joke.
Yeah.
Anyone in the audience who knows prologue will know why that's funny.
Especially,
everyone else would just think you're just geeky.
Especially UNSW prologue.
Yes.
There you go.
Thank you. Okay, and another question?
Hi, my name is James, and I was really interested by your sentiment on having private tutors AIs, and that's something that I've thought about in the past and thought would be really important. But is there any research also being done into when you have these models that represent things like cancer diagnosis, any ways in which you can look back at how that conclusion was reached and find a way to translate it into information which can then be taught to the kind of people who would be trying to diagnose and treat those illnesses?
Yeah, so a few people are talking about this, how to come up with explanations. And I think that's interesting, and I guess it depends on how much resources you want to be able to put into something, right? And so I think what's going to happen is we're going to get to the stage where we decide it's worth putting a lot of resources into making a course just right. And we haven't done that. And in some ways, it's a surprising thing, right? So we have things like we make movies, and we're willing to put $100 million into making a movie and have a huge crew all working together and coordinating towards a beautiful result. But when we go to teach a biology class to 1,000 students, we have one professor and a couple TAs and a budget of basically zero, right? So why do we do that? Why can't we say, this is really important too? Let's nail this problem once and for all and really solve it by going in and figuring out all the explanations. And so I think in the short run, we'll be doing that, right? We'll say it's worth it to us to make that investment, and we'll code the knowledge more by hand than by machine learning. Now, when you get into the more obscure subjects, the independent art films, if you will, rather than the blockbusters, then you can't make that level of investment. And then probably you need more of that type of technology to say, nobody's going to code out everything by hand, so can we learn from examples?
Hi, Peter. Sorry. So when you were talking about jobs in particular and talking about how the idea that these AIs will only empower us to do big tools to allow us to do more. One of the things that occurs to me is that we've heard that a lot with technology, and what we've seen is, yes, we do more, but the top 10% of the population do a lot more and everybody else does a little more maybe. How do you think we can address the burgeoning income inequality through that there's already happening, and it's going to be, I can only think, accelerated by this?
Yeah, I think that's right. And I think, I talked about these technologies as being tools and tools as being amplifiers. And you're exactly right, that often when you have amplifiers, that will amplify the differences. And even in these MOOCs, I certainly saw that effect. In that, on the one hand, I was really proud that we were able to bring technology to people who never would have had that opportunity. People who said, going to college is out of reach for me, but I have a little bit of money, I can go into an internet cafe, I can buy some time, and now I can do this class that I never was able to do before. But for the most part, there's a small number of people falling into that class, but for the most part, the people we were reaching were these college graduates, early adopters, the ones who stand in line to buy the first iPhone are also the ones who are standing in line to take the first online classes. And so it's the ones who already have who are benefiting even more. So I think we need to work hard to make sure that this applies to everybody, but there's no way you can stop an amplifier from amplifying at all levels.
Oh, we've got a tweet.
Yeah.
Please,
We've got a
tweet
few
away,
tweets.
Maury.
We do have a few tweets.
Okay.
There's a question though on the Twitter feed, John Calvo. What kind of research is Google doing to cope with social-related issues by making use of AI?
Okay.
Oh,
Do I have to answer in 140 characters?
no, I think you can
Yeah.
have a longer answer. It's
Yeah.
an important problem. Thinking
Yeah.
about the societal impact,
Right.
and certainly, Mark Zuckerberg has said that AI is going to be quite important in their solutions.
Yeah. So I don't know if we have AI solutions. We certainly have analytic type solutions. So we do a lot of sort of statistical analysis of what are the demographics of who our users are and how can we serve them. We look at how can we serve the developing world and try to understand what their needs are. Although at this level, it's not so much that we have an AI solution. It's often more a physical type solution of saying, well, maybe these guys need some electricity, or these need some internet access, or what these guys really need is water and not anything that's high tech. So we try to understand those issues and connect people with the right answers, and not so much having an AI solution at this level.
I just want to say, I think it's a good question, because it shows that not only is AI perhaps creating some issues that we have to think about, but it's also part of the solution. When Mark Zuckerberg wrote his letter at the beginning of the year, discussing some of the challenging issues that Facebook now faces today with fake news and with filtering content and offensive content that gets uploaded, the only way you can hope to filter on a planet-wide scale is using AI.
Yeah, and we had an announcement just this week of how we're doing more for that. And it's a combination of the AI techniques. So we're looking at things like the offensive videos, the terrorist recruiting videos, and so on. So we're using AI to classify those and take them down. And then we're also using teams of humans to rate them because that gives us more data. And over time, you use that data to improve. And then...
Sorry, I can't let you do that, Peter.
Yeah. And then we're also doing things like saying, well, let's show a public service announcement. This guy looks like he's interested in terrorist recruiting videos. Let's show them a video that says, here's why you might not want to be recruited.
Mm-hmm. I'm not sure one video is enough, but it's a step. It's a step in the direction.
Well, we've seen cases where it seems to actually work.
Good, good. Well, there's a lot that needs to be done. You said there was another tweet.
There are a couple more, but maybe we'll just go through one or two. There's a comment by Matt Baker. Excellent discussion on AI and greatly appreciate Peter Norvig suggesting we need Hollywood budgets for biology lectures. And that was lecture with an R in the brackets, so lectures and lecturers. Question from Nathan Waters. Automation is an issue due to wealth inequality and elite owning AI. Will Google hand over ownership of AI to the commons?
Yeah, I think we're trying hard to encourage that. And so we have a cloud computing offering, and we're making AI a big feature of that. Because we think, we've gone to all the trouble of doing this image recognition and so on. Small company, it'd be hard for them to reproduce that easily. So let's make it available. Let them give us a picture and we'll give back a label for it. And if they want to train it for a specific application, let them do that as well. So, like the model of having services like electricity, we want AI to be part of that service that you can just go ahead and call on.
So one of the challenges there is that you need lots of data, or certainly at the moment you need lots of data. You need lots of CPU. I mean, even Google's making its own CPUs now, TPUs or whatever they're called. Is that not taking it out of the reach of the rest of us, the rest of the planet who aren't Google, who don't have Google server farms?
Well, we'll let you use them, right? So if you, we'll try to rent them out for cheap, and if you have an application that creates some value, then hopefully your rental of our machines will be much smaller than the value you create, and you can keep doing it.
Okay, we've got time for 2 more questions. Can we get a microphone up to the... Oh, we have got a microphone up into the... I was aware that the gallery hadn't had a chance, so up at the top of the gallery there.
So I'm interested in hearing rather about the way that you manage research at Google, particularly with respect to having your researchers embedded in product teams compared to Microsoft, which is more like an academic research lab. So how does that work for you? And how does it impact the way that you engage with the academic community?
Yeah, that's a great question. So we see everybody at Google's job is to create new products or improve existing products. And nobody's job is only to publish papers or prove theorems. And if they want to do that on the side, that's a great thing to do. There's many ways to contribute. But we're all aimed at building products, and it doesn't really matter if your title is engineer or researcher or manager or whatever. These teams are thrown together. And as you say, some companies try to segregate research from engineering and production. And I think the main reason companies do that is they're worried that all the researchers will get sucked away, that the manager of a product will say, yeah, I know you're doing this long-term research thing, but we got a deadline coming up next week. So just for this week, could you pitch in and do that? And then 1 week becomes 2, becomes 3, becomes 4, and pretty soon nobody's working on long-term research. I think we're pretty good at protecting against that because we have a lot of things going on, and because we have them going on at different time scales, and because most of our products have continual updates, right? So in some industries, you ship a product once a year, so there's a deadline and there's pressure to meet that deadline. For us, it's most products, they're in the data center and they get updated every day. So there's more of this continual feeling. It makes it easier to say, here's what we're going to do short term, and here's what we're going to do long term. And so we can have these teams integrated together. Now, sometimes this does cause problems. We get like new PhDs who come in and say, I'm used to doing research. This is a different way of operating. And most of them, after a while, they find that they really like it, and it's rewarding for them to produce products that are used by millions or billions of people. And if some of them don't like that, then there are other places they can go and be happy and publish their papers and work on pure research.
Just a little follow-up on that. You absorbed DeepMind into Google. Did that change the research methodology, or is that the DeepMind
So
way of thinking slightly different or the same?
So they're a little bit more research-oriented than we were, and so we gave them a bit of autonomy to work separately. You know, so they're part of the company, but they're also separate from the company. And we're happy with the returns because they're doing great theoretical work, and then they're also connecting with these applications.
Optimizing your data centers and all these sorts of things. And beating the Chinese at Go.
There you go.
Okay, one last question. The gentleman at the back.
Hi, my name is Alexander. I'm really intrigued by your talk and everything you mentioned about machine translation. I used to work as a translator for a number of years, and I know how hard it is. Do you think we're ever going to get to a level, to human level, machine translation, and how long is that going to take? And are we ever going to get to a level where machines can instantly translate speech from any language? You know, as a professional translator, I used to think this was the last job that was going to go. Well, it was very secure, but
you want a Babel fish, right, in your ear?
Yeah. So, what do you think? Are we ever going to get to that level?
Yeah. So we break it out into two parts: the written and the spoken. And in the written, we're getting pretty close to human level performance. One thing we're finding is that human level performance isn't always that great, that human translators make mistakes too, right? Because they've got a deadline, they're going fast, they didn't quite understand the source material, and so they said the wrong thing. So maybe it's not our goal only to reach human performance. Maybe we should try to correct all the mistakes that humans made as well. And I don't know to what extent we'll be able to get there, right? So we've cut our error rate in half over the last year. You know, maybe we can do that again next year. I don't know how many times we can do it and how much delta is still left. And there's some things where you really need to understand the world in order to get the right answer, right? So if I say, I dropped the glass on the table, it broke, then you understand that it means the glass, and if there's a language where that has, you have to decide if it's feminine or masculine, you make the right choice. And if I say, I dropped the bowling ball on the table, you understand that it's probably the table that broke. And that doesn't have to do with linguistics, that has to do with physics and the real world. So I think to get those types of things right, we're going to have to teach our machine translation system what the world is like. And so far we've been training it by saying, here's examples of text. Here's text in English, here's text in French, they correspond to each other. Now you figure it out. If we wanted to get all those things right, we're going to also have to say, you know, here's all the YouTube videos in the world, and here's how glasses fall onto tables. And now, in addition to understanding the structure of sentences, you also have to understand the structure of the world. And nobody's tried to do that yet, but to get to perfect translation, we'll need that. Then the second part of the question was, if we're going from written to spoken, we're pretty good at speech recognition. We can do okay at generation, but we don't quite get all the emphasis quite right, and the pauses and the the nuances of sounding just right. So if you're willing to have kind of a flat or mechanical speech, I think we're pretty close. If you want to have a nuanced speech, we got a ways to go yet.
So if I can paraphrase your answer, you're actually saying the gentleman's right. We can't solve the machine translation problem till we solve AI.
That's right, yeah.
So you're right. It
Yeah.
is the last problem we solve.
Right.
Okay, Peter, it's been a great pleasure talking to you, and thank you very much for sharing some of your
Yeah.
insights
Thank
about
you,
what's
Toby.
going on in AI and Google.
Right.
Before we go, I've been asked to thank a few people who made this event possible. Amy Lees, Jane Edwards, and Marcia Svensson from the Faculty of Engineering Marketing. And I apologize, I didn't get given the name, the student ambassador who I think helped with the robots. So thank you very much, all those people.